solution to anything.
Yeah.
Yeah, I mean, what is a solution? It's, in this case, some function, or in algebra, it's some number that satisfies the equation. That is, after substitution, the left-hand side and right-hand side become equal. Okay? So if you'd like to verify that a certain function is, in fact, a solution to a certain differential equation, then all you need to do is substitute it into the equation. Okay, so I'll do the first, and then you guys can try the second. Okay, so we've been given this equation. Okay, and then we're going to check that y equals minus x cosine x is solution. So what do I need to do to check that this is in fact a solution?
Place y in the value of y in there,
Yes, I can substitute y here.
and then take the derivative of.
I also need to substitute the derivative, so before I begin to substitute, I need to first find the derivative of y. Okay? And I should say what it means to satisfy this equation, right? If you check that some number is a solution to some algebraic equation, you want to get some number on one side equals some number on the other side. Okay, this is going to look a bit different because we'll have on the left and right-hand side functions of x. Okay, so in algebra, you know, if you get an equation like this, right, then one is a solution to this. Okay, in differential equations, if at the end this is what you find, that means that whatever it was that you began with is in fact not a solution, right? I mean, this is called a conditional equation. It's conditionally true. If x is equal to 1 or 0, then it's true. If x is equal to something else, then it's not true. Okay? What we're looking for is an identity. It has to be true for every single x. Does that make sense? Now, there are some things that I'm glossing over that the textbook discusses, that talks about intervals of definition. Okay? So most of the time we'll be seeking solutions that are true for all real numbers, but you can restrict that so that your solution satisfies the differential equation on some interval. I don't want to get into those technical details because it won't be terribly important. But you want it to be true for at least some interval of values for x. Okay, so it has to be identically true. Okay, so help me find the derivative of y.
Would be x squared sine x.
I think you were thinking of an integral. So I need to find the derivative. What do I need to use to find the derivative of this expression?
Product rule.
I need to use the product rule, right? So how does the product rule go?
First.
Yeah. So I've got a product of two functions, x and cosine, right? So I take the derivative of one of these factors, leaving the other on its own, and then keep the first, take the derivative of the second factor. So let me write this out. So I need to find the derivative of negative x multiplied by cosine. Then I need to take x multiplied by the derivative of cosine. Okay, so derivative of negative x is
Negative x is negative 1.
negative 1, so this is negative cosine x minus x times derivative of cosine. What's the derivative of cosine? Negative sine. Okay, so it's negative cosine x plus x sine x. Okay, so now we're prepared to substitute. Okay, so substitute for every expression of y, including its derivatives. Okay, so we've got x times, here's the derivative. Okay, minus y, here's y. Okay, and we're checking to see that this matches precisely x squared sine x. Okay, so put a question mark because we're not sure that this is true as of right now, so this is minus x cosine x plus x squared sine x plus x cosine x. This is equal to x squared sine x. Well, after simplification, we get this, we have left-hand side, right-hand side, precisely the same thing, okay? So it's not just true for some x, it's true for every single x. So that means that this is in fact a solution to the equation. Pretty simple. Okay, we won't be doing a lot of this. We're going to be finding the solution rather than verifying the solution, but it's important to know what the meaning of these are. Okay, so we've got 5 minutes left, so why don't you all try number 2. Okay, and you should understand the c to be a constant. Okay,